In this video, we are going to learn how you can create any MCP server, run it remotely, and also answer related interview questions. And we are also going to go over the pros and cons of running MCP server locally versus remotely. I'm going to show this example by running a MCP server in Kubernetes on AWS Cloud. The important part is to understand the concepts so you can run this MCP server in any AWS service really, EC2, Lambda, or even in other clouds. Which brings me to the first question. What the heck does MCP server mean? You as a user may send a command to the agentic application which has access to some large language model running some agentic code, say perform X. And you may have access to a tool which does X, right? And you can have multiple tools like this, say perform X, perform Y, and then this agentic code just calls this tool which does X, another tool which does Y. So let's take a simple example. Let's say you wanted to add two numbers, A plus B, and this tool, let's say this tool returns C equal to A plus B and just returns it, will that be MCP? No, right? That's a regular API call. That's where MCP come into the play, and this part is important when you create any MCP server. So MCP standardizes the communication between the MCP client and the tools. So in MCP, you don't need to connect to the tool directly. All you do is connect to the MCP server, and MCP server handles the communication with the tool. But there is more, okay? So why is this called MCP protocol? This communication between the client and the MCP server. Well, some stuff happens. It dynamically discovers some critical components. In the beginning, MCP client connects to the MCP server. At this point, MCP client does not know what fields it should send. Then the client asks, what can you do to the MCP server? Then the server responds with list of available tools. The server may say, hey, I add two numbers, A plus B, or I give you the weather. My input is name of a city, output is weather in centigrade. And then the MCP client registers these capabilities and makes them available to the LLM. So when you ask the question, at this point, LLM knows what tools it has access to, and then based on this dynamic discovery, it can call the appropriate MCP server and the underlying tool. So as you could see, there has to be some standard protocol, and Anthropic has defined it. You should expose your MCP server with the endpoint /MCP, and it needs to support some specific JSON RPC method. For example, tools/list. So I should be able to call the URL of the MCP server and then /MCP, and then this is JSON RPC, so everything is post, right? And then if I send tools/list, it should give me all the list of all available tools exposed by the server. If I want to call those tools, I should do tools/call. And this is standardized, right? Another agent, if they say, I want to do tools/execute, that's not going to work. But the beauty is, but because this standard is published, even tomorrow, if there is another agent, so let's say this is Claude Code, right, or Cursor, or even your application, you know how to talk to this MCP server. It's all the same. You know you need to send tools/list to list the tools, tools/call to call the tool, etc. And then there are some more specification. When you call these endpoints, you should have including the JSON RPC, method, parameters, and ID fields. Okay, and this is a huge documentation, and I'm going to show this in demo how this works in action. You will see tools/list, tools/call, etc. And then we have a bunch of examples on how you should call. So you should call tools/list like this, tools/call like this, etc. So at this point, we understood the core fundamentals of MCP. So in the interview, if they ask you, how would you write an MCP server, Don't just jump into, I'm just going to write it into a Lambda. I'm just going to write it into container. You have to explain that what things MCP standardizes, /MCP endpoint, tool/list, tool/call. It has predefined format. Based on that, you wrote and implemented MCP server. Okay, now let's go to writing MCP. So at this point, we know just calling an API endpoint, passing the input variables, and getting the output is not MCP. So to do that, you need to write a program with those following the MCP standard. Most of us are running MCP server in our local, so there is a big distinction. So let's say this is my laptop, and I have a bunch of videos where I run MCP server in my laptop. You can go check it out. The big difference is transport mode is stdio. So stdio is basically in your code. You can have std in to accept something, std out. But this does not work when the MCP server is running remotely. So let's say we are running the MCP server along with the tool in Kubernetes running on Amazon EKS, and I exposed it through a load balancer, okay, load balancer service. You cannot use stdio because that's only for local. So this is your machine, this agent and code is running in your machine, and you are connecting to this load balancer. The communication protocol is streamable HTTP. So I know with GenAI, everything is like freaking fancy, right? Like we don't call it plain English, we call it a natural language. Similarly, what the heck is streamable HTTP? So let me try to explain real quick. So let's say you are the user here, and then there is this application load balancer, and then let's say this is EKS, okay? If this is regular HTTP, not streamable, okay, this is regular HTTP, you send a request, and only when the request is fully processed, and then it will be returned. Whereas in streamable HTTP, so let's say SHTTP, you do not have to wait for the full answer, okay? So even if this MCP server has a little bit of information in chunks, it can send it to you in chunks, okay? And then when it gets the next chunks, it can send the next chunks, etc. This is the latest jazz. Before, MCP used to support stdio for local and SSE or server-side events for the transport, but now streamable HTTP replaces SSE. Okay, how does the MCP implementation looks like in this case? So the MCP code is just a piece of Python code, and I'll explain what does fast MCP do in a second. And to create a container image, you have to have a Docker file, right? If you are a subscriber to my channel, at this point, you should know what is a Docker file. So this container image is saved into a container registry. So in this case, we are using Amazon ECR. And then we are deploying this into a Kubernetes cluster running in Amazon EKS. So this MCP server along with the tool as well. And then we have to have a way to invoke this, right? So we are exposing this Kubernetes container using an external service, which is load balancer. You can also use ingress, but that's beyond the scope of this. And then you can invoke this load balancer using any MCP client. Okay, that's the beauty of it. You are not just calling the URL and passing two variables. Any MCP client can call tool/list, tool/call, and invoke this MCP server. Okay, with that, let's jump into the demo, and some of the concept will become clear. So this is the MCP server code. So there are two ways to implement all the MCP protocol. One is you can of course go code everything yourself. So I'm going to switch real quick. So if you see this, in this, I literally coded all this stuff, right? So this is the tool, this is all the defined standard, JSON RPC version, these error codes are all defined by Anthropic. If I scroll down, I should have a tool/list. Okay, here we go. So as you could see, I have implemented tool/list. I have said what to pass, so it's going to pass basically this information, this will pass this information, and then I should also have a tool/call. Here you go, tool/call, etc. But this is very tedious and error prone. So the best practice right now is using this library called fastMCP, and this fastMCP can grab things from your code and create tool/list, tool/call, and a bunch of other protocols. You don't have to go hard code those error codes here. It's just baked in here in the fast MCP. If Anthropic changes anything, fast MCP, as soon as you upgrade to the next version, it has all the changes, all the good stuff, okay? So as you could see, in this code, I am defining my MCP tool. This MCP tool for this example just takes two numbers, A and B, and then returns A plus B. But then look, I had to put a little bit of description here, and this will come into play because fast MCP will take this and return when someone is trying to dynamically discover what the heck this MCP server does. And then I'm using streamable HTTP as the transport, right? And I'm running this in port 8000. Okay, next is Docker file, right? Like I said, pretty simple Docker file. I'm grabbing everything. I'm installing the requirements.txt, which should just have fast MCP, and then I'm exposing this on port 8000. So if I go to requirements.txt, fast MCP, nothing crazy. So let's run this Docker file, create the container, and push this to a ECR repository. All right, so I ran a Docker build, and then after it is done, I created a repository, and then I do a Docker tag, and then simply Docker push. All right, so if I go here, you could see the repository, MCP calculator, and then you can copy this URI, and we need to use this in our Kubernetes deployment file, right? So if I open up Kubernetes deployment file, so this is a pretty simple file. So basically, it's a deployment, and this is the image URI, right? So I'm just going to paste this, right? Save this, and then if I scroll down, I'm exposing that deployment using a service. This should be type load balancer, and exposing it for both port 80 and 8000. So let me save this, and then I already have a EKS cluster running, so nothing fancy there. So if I run kubectl get node, I should see the node running, okay? So now I will simply do kubectl apply-f k8s deployment.yaml, and that will deploy this container. All right, so in my console, I have this MCP calculator cluster running. This is just a Amazon EKS auto cluster, and this is running in a worker node. Geez whiz, C6L large. This is expensive. Look, I'm spending real money, okay? You better subscribe and like this video, okay? All right, so if I switch to my Visual Studio Code, and then if I do kubectl get pod, okay, so this is running MCP calculator. And I should also have a load balancer running. So if I scroll down, load balancer, here you go. So this is the load balancer DNS name, right? K8's default MCP calculator, and this is what we are going to use. Okay, so at this point, our remote MCP server is basically running inside this pod. So let's test it out. So what I'm going to do first is show using curl command, and then I'm going to give you a Python. All this stuff I'm going to share in the GitHub. Please like this video, put a comment, trying to grow this channel, help a brother out, okay? So let's run some curl commands. For streamable HTTP, the default session duration is 30 seconds. So I'm just going to run the curl commands fast, and then I'm going to explain, okay? Because if it expires, if the 30-second passes, the session ID is gonna change, and then I have to reinitiate the connection, all that stuff. All right, it ran. Let me make this a little bigger. So first, remember, for streamable HTTP, I need to get the session ID, right? So what I'm doing is simply curl, and then that endpoint, and method is initialize, and then this should give me the session ID. So I'm just echoing the session ID, and then after I have the session ID, all the communication needs to use this session ID. So then I'm going to initialize the connection using the session ID. So you could see the session ID here, and then the actual processing starts. So let's see, there should be a tool/list. Here we go. See, method. Okay, see, I'm using the MCP session ID, the same one that we created, application/JSON, tools/list, right? So it sent the tool/list and it got the message back, hey, JSON RPC 2.0, ID is 2, result, tools, name, add numbers, description, add two numbers together, arguments, A is the first number, B is the second number. How is it getting all that? Well, if I go to our MCP server code, this first MCP is basically getting the name of this paragraph or name of the tool from here, and then the description from here. It also has access to the parameter. It can say it accepts two input parameters, A and B, float, etc. Right? See, this is doing this dynamically. The client does not need to know this. So once you call this, then you know how to invoke this MCP server, right? So imagine in real world, you have access to tens of MCP server and you can dynamically discover, get the description, pass everything to LLM, and LLM can intelligently call based on this description. So if I scroll down, I should be doing a tool/call. Where do you go? Here we go, tool/call using the same session ID. I'm saying, hey, call the tool which has the name add underscore numbers. Arguments, I need to pass 2, right? A is 15.5, B is 24.3, right? And then I'm using the same load balancer. And also see /MCP. See, it implemented /MCP, that's fast MCP as well. Okay, and now I get the message back, ID 3, result, content, text, 39.8. Excellent. All right, so our MCP server is in business. So now any MCP client in the world can use this tool. By the way, I have put everything in a README file as well, like, hey, you need this file, and these are the steps you need to do for EKS cluster, as well as how to test it, right, using the curl commands and stuff. I will give all the link in the description. All right, so the last thing is, in real world, you are not gonna execute curl commands in the terminal, right? So your MCP client will be running in a code. So that's the last piece. So here, this is a sample code. So in the beginning, you need to know the server URL, which is the load balancer /MCP, right? And then you are creating the streamable HTTP client. The same thing we did in the commands, we are doing in the Python code. So basically using server URL, you connect, and then you need to get the session ID. And then you create the client session. Basically, you are initializing the session, and then session should be initialized, and then you need to invoke tool/list. So tool/list is in the curl command. So in the Python, it is list underscore tools, right? And then whatever we are getting, we are going to print, and then we are going to call the tool, right? Add numbers with the test case, passing 15.5, 24.3, should get the result. Okay, so let's try this out. I think this one is in container MCP. So if I do Python 3, fixed MCP client. Okay, this should work as well. All right, so this worked as well. So as you could see, initializing session initialized successfully. Okay, and then it found one tool from the list tool call. Add numbers is the name of the tool. It adds two numbers together, arguments for A and B, returns, testing 39.8. All right, the last thing I want to go over is, should you use your MCP server locally or remotely? There are some big advantages of running the MCP servers remotely. So we implemented this part, right? So if I get my trusty pen, right, load balancer to EKS, this can scale, right? Because load balancer can scale under the hood, and then you are basically running a container in EKS using horizontal pod autoscaler, Carpenter. You can scale out the MCP server. Can be used by many clients. If your MCP server is running in your laptop, external clients cannot use it. But here, this is literally a load balancer URL, so can be used by any other customers. You can implement authentication authorization, right? Because remember, this is just a load balancer, and with load balancer, you can integrate Cognito, And then when we invoke this URL, we need to pass those bearer tokens. And this is how prod MCP server will be implemented. And I'm just showing you an example with Kubernetes, but you all are smart guys and girls. Like I ran a container on EKS, you can run it on ECS. You can run this as a Lambda. You do have to do a little bit of extra instrumentations because Amazon API Gateway does not support streamable HTTP for REST API. You have to do a little bit of jerry rigging, but you can use Lambda with load balancer as well. In that case, that should work. You can run with EC2, etc. However, when you run your MCP server locally, it's secure because you are literally communicating with it from your laptop. So there is no traffic going through internet, there is no man-in-the-middle attack, etc. But what do we say? The most secure computer is the one that's not attached to the internet. It's also the most expensive paperweight, right? And this is the thing. You might say, oh my God, I'm running this MCP server. This MCP thing is new. What will be the cost? The security, the observability, scalability, reliability. Remember, this is just another piece of code running on the cloud on a service. You can implement the same best practices to cover all of it. So for example, you want to secure this MCP server, all right, put appropriate security group, put network policies, because at the end of the day, it's just running in container. Scan the code before you containerize it, and you can restrict what it can and cannot do. Same thing for cost optimization, observability, scalability, reliability. You can reuse all your existing ecosystem, right? If today you are using Splunk for logging, all right, you can keep on using Splunk for logging this MCP server activity. If you're using CloudWatch Container Insights, you can keep on using it. If you want to make it highly available, all right, deploy it into availability zone, etc. So I know this is a little bit of longer video, but hopefully this was useful. My goal was not to just give you a code so that you can run and feel good. My goal was to teach you the underlying concepts so then you can go create and implement any MCP server by yourself as well as answer interview questions. All right, folks, that's it for this one. I'll see you guys and girls in the next one. Bye.